Welcome back to the channel, everybody. Today, as we continue on our discussion series of different topics, Mantis and I thought we would really showcase our true nerdism, as we have discussed in many videos that we are obviously huge comic book nerds, but we are also nerds in the sci-fi realms as well. Mantis, I know you're a big a fan. Actually, Mantis is the one that got me interested in Stargate, so that's kind of your fault.
Mhm.
But Star Trek, Star Wars, obviously, anything of the stars,
Mhm.
we are also big fans
Yes.
of.
Yeah. This video is going to include obviously superheroes and that type of stuff, but we're going to kind of dabble in the science fiction realm as well. Because superheroes are kind of science fictiony too. I mean, there's aliens, ghosts, all kinds of weird stuff that happen in comic books. So I feel like it's all fair game.
Well, they are science fictiony, but then they're also not because they violate a lot of the laws of science, and that's part of what we'll be discussing today. So I apologize. This episode might be a little nerdier. Now, full disclosure: Mantis and I are not astrophysicists. Okay, we've taken an
No.
interest in the subject just because as we watch these shows, we're kind of curious to see how real they are, as well as it gets you interested in science. Right? You watch these ships moving faster than light and warp speeds and things. You want to know more about the
Mm.
topic to kind of bring you into the show more. So, you do your research. So we're by no means experts, but we do want to share kind of our opinions on some of the things when we watch, say, these superhero shows. We're like, would that really happen or would everybody die? So,
Right. Or like a question like continually comes into mind when I'm watching these movies and these shows is like, how many times can you get knocked unconscious before you have brain damage? Because I feel like people get knocked out because it's a common trope. I mean, I'm gonna call out the main one that we're familiar with, which is Smallville. But Kristen Crook's got to have brain damage.
She's suffering from cerebral edema, which may have caused substantial brain damage.
I mean, or Lana in the show, but in other stuff, like you just see people getting thrown around, and it's like, how many times has this person been in the ER? Like, are you just that bad luck? Like, what's going on here? You know?
So, and if you haven't watched it, I apologize. Spoiler alert, you should already be prepared for it. But it's been out for years, so it's kind of your fault. At the very
Mm.
beginning of what was it, end of season 3, beginning of season 4 of Stargate Atlantis, Weird gets thrown back due to an explosive force, and she
Mhm.
suffers like irreparable brain damage, and they have to do a craniectomy, and because there's so much swelling, and Smallville, they're thrown around all the time. It's just fine. Take some
Yeah,
Advil.
I
You're
want
good.
I I want a clip collage of every time Kristen Krug or Lana gets knocked out and how many, and put a counter. Ding, 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 ding.
I'll
That's what
do
I
that for one.
want.
However, I mean, expect it to be in high double digits by the time we get to like the end of her run, or at least the first time on her run on that. So, uh, with that in mind, though, like we've talked here recently about like shows like the Flash movie. We did our reaction to it. If you haven't checked that
Mm.
out yet, go check it out. The movie was pretty good, and it was the first time that actually, Mantis and I had never seen it, so it was an original reaction that we got to share with you guys. But it brought up a lot of questions for us when we were watching it, and we discussed after the fact about how realistic is that as far as being able to move that fast within the world, like within planet Earth, right? Because
Yeah.
at one point he's moving faster than light, which technically isn't theoretically possible. Um, well,
Do tell.
I take that back. Okay, so here's the thing, and the Flash TV show kind of points it out. We're talking theoretically possible. There is a theoretical
Mhm.
particle called a tachyon, which actually travels faster than light. And the interesting thing about tachyons is that because they naturally start out traveling faster than light, as the particle reaches entropy, right, as it loses energy, it would actually go faster and faster because to go to the speed of light, it would require infinite energy, right? So if you start
Mhm.
out faster than that, as you lose energy, you couldn't approach the speed of light barrier again. So you would actually get faster and faster. Now,
Faster and
does
faster.
that make a whole lot of sense to the average Joe? No, but again, it's a theoretical particle, so all this is kind of theoretical.
Right.
It's the name.
Yeah.
However, obviously with Einstein's theory of special relativity, E equals mc squared, energy equals mass times acceleration squared. uh, no object with any mass can reach the speed of light,
Speed of
right?
light.
Because
Right.
as you approach the speed of light, you gain exponentially more and more mass. And as you get to the speed of light, you would have any object with mass would have an infinite mass, which would then require infinite energy to move it along. So in the Flash, when you see him moving at the speed of light, you're like, well, I don't think that little candy bar he stole from the vending machine is going to power him enough to go to the speed of light. Right.
Right. I appreciate the fact that they try to, I mean, and this has technically nothing to do with that, but it gets more of the physiological effects of the Flash, right? The way the Speed Force works with him. Somehow it gives him super speed, but it requires, energy for him to use that. And, apparently it's in the form of calories, which is interesting. Uh, and it's a funny way, the writers, I'm assuming, and I don't know, you guys comment down in the comments of the earlier Flash comic books and stuff. Is that something that they wrote in there of him doing, or is that something more recent that they kind of try to explain how he has to refuel himself, right? Um,
For a long time throughout the comics, I can't tell you when it started, but it's been a long time. It's been a running kind of gag that he always has to eat, right? You even
mhm.
saw in Smallville when he wolfs down, and Martha's like, "You eat more than Clark, and he's twice your size." They've always played it, and even way back further, they've always played it that yes, he has to consume a large, because you got to figure. I mean, Michael Phelps, who's the top Olympic freaking swimmer in the world, he eats 9,000 calories a day just to be able to swim and train. Can you imagine running at those speeds? How much food you would have to
I
put down?
right. It would be, he would just be eating all the time, right? Like, you know, yeah.
The Flash TV show, they make it where they make these condensed super bars that are like 10,000 calories a piece, and he wolfs those down. Because, I mean, yeah, it would take, especially again, when you're talking about, again, approaching the speed of light, you're going to need infinite energy if you were an object with any mass to hit the speed of light. And he's going faster than the speed of light. So it's kind of like, all right, well,
Is
they,
there
they
any air friction there?
well, so there's the other thing too, and let us know down in the comments. I know there's probably going to be some that watch it that want to nitpick what I'm saying, because they're going to say, "Well, the Speed Force allows him to, be able to move that fast." Well, here's the thing: you can't have it both ways. You can't say the Speed Force allows him certain luxuries, but he still interacts with the environment in certain ways. Like, in the movie, he says,
Right.
well, you can't move a human at hypersonic speeds like that, which is true. You would
Right.
kill him. But he's like, but you can move a microwave. And that's why he puts the really fake looking Cabbage Patch CGI baby in the microwave and moves it. So clearly it shows he's interacting with the environment. However, if you're moving anywhere close to even half the speed of light, I'm not using that as the set point, but I'm just saying, let's say, for example, half the speed of light, the faster and faster an object moves, the more the friction between the object and the air molecules is what creates heat. Okay, so if
Right.
you're coming closer to the speed of light and you're an object moving that fast in the atmosphere, you're going to heat up so much so that while you can't technically catch the atmosphere on fire, that the scientists have proven there's not enough actual oxygen
To do
versus
that.
everything else you need to make it flammable. But you can superheat the environment and the atmosphere up to where it make the planet unlivable, moving that fast within the atmosphere, right? As well,
Gotcha.
we're talking sonic booms, and there's, again, you've seen the effects in Flash and Superman, what the sonic booms do. They shatter out windows. They do all of these
Mhm.
great, just because of the force of hitting past the speed of sound. So
Yeah.
clearly they're reacting to, or the physics of them moving that fast is reacting to the environment. So if it's affected by the speed of sound, you can't tell me that's him or Superman get
It's
closer to the speed of light. Now it's just null and void, right?
Yeah, and again, I do want to point this out. You kind of mentioned it. Like, we understand that these things, this is fiction. Okay, we understand that it's a comic book, but we're trying to play devil's advocate here with the reality if if this stuff was in our, if it was in, like reality. It's not not in comic book land where things, are just however you write them to be.
Well, kind of like, and that's why we began with the beginning of the show of talking about like the science fiction movies and TV shows like Stargate
Mm.
things, where they do have to consider, wait, we're in reality. We can't just say this.
Yeah.
We have to show what happens when you're moving. Hence, they have like inertial dampeners that they create.
Mhm.
That
Star Trek did a good job of that. Yeah, I mean, in they did a good job, and this was, of course, earlier. Uh, when did the first Star Trek
70s,
series come out?
60s, 70s.
60s, 70s. Yeah,
I
like
think the
they,
70s was when the Star Trek, the series, the Next Generation series started. Or
yeah.
not
I
Next
mean,
Generation, but Star Trek, the original series started.
right. They kind of thought of some of this stuff. Obviously, when the Flash was written, tachyon particles, I don't think they knew those existed, right? Like, maybe, I mean, I wouldn't think that they would. So, they're guessing on some of this stuff, which is fine. It's all in good fun. But again, we're in the future now, right? So we can kind of poke fun at this. It's like, this is not reality from what we know now, from the science that has been done in the past 50 to 60 years. We know at this point that that's just not a thing.
Well, it's funny you say that because in Star Trek, they don't ever like technically go past the speed of light or even to the speed of light. They go into warp, so it
Warp,
actually
right?
warps space time. So while they're displacing themselves, they're not actually the velocity isn't there. It's just displacement. So
Right.
they're warping and they're bending space time. So they got around that. We're not actually traveling faster than light.
Yeah, I kind of want to explore that, like, because you brought up Stargate. There is an episode in, I think it's in Atlantis, where they catch up to one of the ancient ships. I say catch up. They see one of the ancient ships, that is traveling at really, really close to the speed of light, right?
Point
And
nine nine
they've
nine
been
nine the speed of light.
yeah, they've been traveling for forever, right? This ship, it's been, in fact, if I remember right, and you can correct me if I'm wrong, they had a ship full of ancients that were in hypersleep, right? And the computer was controlling them through this voyage because, again, time slows down the closer you get to the speed of light, right? So for them, it hadn't been that long that they'd been traveling, but the
So
ancients had been dead, quote unquote, dead for ages, for centuries, right?
So yes, in the show they're going at 9.999 the speed of light, so as close as you could get without time completely stopping. However, in the show, with the war with the Wraith, that was 10,000 years ago. So they have been traveling for 10,000 years. Now for them, it only been a couple of years, um, and they were able to get a million light years away without. And he makes the comment, he goes, "That's how they were able to get a million light years away from Atlantis without
Mhm.
having to leave a million years ago."
It conked out on the way, and they were forced to continue it as close to light speed as possible. That would explain how they got a million light years away from Pegasus without having to leave a million years ago.
Because obviously
Right.
relativity comes into play. And when we talk about relativity in the sense of like we say like with Flash or something like that, where it's on a lot smaller scale, he's only moving at those speeds, for brief seconds and things like that.
Mhm.
But basically, if you were able to go with the speed of light, for every 1 second you as the traveler experiences, the observer would experience 18 seconds. And same thing, if you were to go travel at the speed of light for a minute, it would basically be 18 minutes. Now, again, I'm not smart enough to do those calculations. I got that from, there's a great site I go to try to like learn all this stuff, and they have it's called a time dilation calculator. Basically, you put in the
Mm.
speed and the distance, and it'll tell you what the difference is, what the travelers. I'll either link it down below in the description, which I'm really bad about. Most likely, I'll just paste it below us on the
Mhm.
background here and post there. So if you guys want to check it out, you can. But basically, that's kind of what it boils down to. Because, like I said, I'm not smart enough to do that math.
Gotcha. So that's
So
different. Like going light speed, that's different than, quote unquote, you'd say black hole or warp, right? Like in the Star Trek series that they use, where, I mean, you're not increasing the speed. You basically have 2 points in space and you bring them close together, right? Is that kind of the gist of it?
kind of. So there's a couple of different ways it's been portrayed throughout the sci-fi realm, where they warp space, so it's not like taking two points in space and folding them together like Event Horizon. They have
Oh,
a wormhole drive, basically a black hole drive, where they start out here, they're trying to get here, and it just folds space time to where they're the same point, right?
It folds space so that point A and point B coexist in the same space and time.
You go into this part of the hole, come out at this part, and you're on the other side of the universe.
it's like Portal. It's
Yeah.
like the game Portal. Yeah.
Whereas
Okay.
Star Trek, it warps it space. So again, you're displacing yourself, and it's warping through space time, and it's bending, but not completely folding in half. Whereas, yeah, like, and again, you kind of run into when we talk about time dilation. For those of you who don't know what time dilation is basically where time slows down within a certain localized field as opposed to everywhere else outside, and how everybody else would experience time. And that's done in two different ways. You have relativistic time dilation, which is what we've been talking about, moving closer and closer to the speed of light. Time slows down because you are warping space time as you move that fast, but it's due to the relative velocity. Time slows down for you. Again, if you could hit the speed of light, theoretically time would stop for you.
Right.
Versus if you approach a black hole, you experience time dilation in the form of gravitational time dilation. Gravity wells so strong that it actually warps space and time to where then time slows down the closer you get to the event horizon of the black hole.
So you see that in again, I'm going to stick on the science fiction-y part here because of the black hole stuff. But if you've seen Interstellar with Matthew McConaughey, this is they demonstrate this very well in that movie of him going down into close to the planet, and time is like they talk about it. He comes back up to the back up to the ship, and it's been years. He for him, it's only been a short while, right? So.
Yeah, they tell them when they go down to the planet, like every minute or whatever you experience on the planet, X amount of times passed on. I can't remember exactly what they said, but it's passed on Earth.
Right.
It's crazy amount.
Yeah.
Right. Again, like you brought up the Atlantis when they talk about, they left 10,000 years ago. For them, it's only been a handful of years, because using the same calculation, let's say they've been traveling for a year. Well, 18 had passed, outside, and vice versa. That calculations based on if they hit the speed of light, but it's relatively close. So when you think about the Flash, again, if he's moving at the speed of light, and let's say that whole hospital scene took a minute, right? Well, 18 minutes passed for everybody else while he was doing it. Now, time slows down to basically stop because they're doing it as that's his perception, right?
Exactly. You see that from his view.
But if you're moving that fast, it looks like time, like everything is
slows down
for you. However, they're not doing it on the time element, right? They're doing it just because that's how somebody moving that fast would perceive the rest of the world. It would look like they're standing still. They're not taking into account relativity and the fact that, it took him a minute to do all that, and he would have been out of place 18 minutes for everybody else.
In the show, you get to see both sides of that, right? I mean, you see it in other shows with speedsters and other fast moving, where you'll get to see the perception from the other characters in the show or the movie, where Flash is he's the Flash, right? He's like, vroom, 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 right? Just doing that. But then also you get to see it from his perspective, where he doesn't feel like he's going fast. It just looks like everything else is moving slower.
Or not at all.
Or not at all, right?
Because he hits a couple of those times in the speed. So again, it's one of those things that is it necessarily a big deal, but you're like, okay, so by the time if he spent a full minute clearing out that hospital, 18 minutes would have passed in real life, and that's not shown. They don't do that because it's kind of one of those they try to get away with. Well, we follow certain rules of physics, and then we break other ones, and we'll come up with one line of dialogue, and it'll fix all of that. It's just it's kind of funny to me. They really, like, if you're gonna play it as a superhero, like Superman he carries Lois all the time in other TV shows, or Smallville especially. He moves super fast. Those people would be fucking dead. Like you cannot
Right.
accelerate a human that fast without killing them.
Right. It's funny because you mentioned we were talking before about the guy that has the gun on Lois, right? And Superman comes over and just pushes him, right? And he goes flying through a brick wall, right? I mean, and correct me if I'm wrong. I know the speed part does make sense as well as him going so fast. It's like a bullet, right? Like you can't put out that mass into a bigger space to where there's not a like an endpoint, like an impact point where all of the force is going into one particular spot. If you did it like I remember watching an episode of MythBusters, I think, where they had dropped a dummy from like because they were testing water tension. So they
Mhm.
dropped a dummy from I don't know how high it was, but they did it in still water and they did it in like wavy water. And the same concept applies to divers. You know, if you ever watch diving, professional diving, that is, especially from really tall, like high diving, they'll have a jet that's like a just like it's like a little fountain that's shooting in the pool right where you're supposed to land because it breaks up that surface tension, right? Because when they drop that dummy on like water that hasn't had the water tension broken, the damn thing explodes. Like the dummy just explodes. It's not like it went down and whatever and went flying through a brick wall. No. I feel like if he came up and hit you that fast, like you would literally just explode. Like your body would explode.
Well, and it's a little different when we talk about dropping a dummy, and we've all heard the, if you hit flat water from high enough, it's like hitting concrete, right? Dropping a dummy
Yeah.
at that speed versus, again, like you had pointed out, when Superman in Man of Steel is what we're referencing, for those of you who don't know, when
Mm.
he tries to save Lois and he like super speeds at that guy, there's certain points, whether it be fingertips or hands, that hit that guy. Like it wasn't a whole wall that pushed him, right? So then his whole body would
Mhm.
explode all simultaneously. Those points that grabbed that guy at the speed he was moving would have just went straight through that guy.
Through. Yeah, it's like a bullet, right? Like if you hit someone with a cannonball or a bullet, the same speed, right? Like the weight displacement, I guess, is what I was talking about. Yeah.